Hi there, this is Mark Espenheid again, and I'm going to take us through the steps of deriving the equation. Okay, so as we said, we have been working with geometric sequences and taking and extending that idea into a geometric series. So the general rule for a geometric sequence that we've used is Gn equals G1 times r to the n minus 1 power. Okay, and this here we've got a future term. We've got the first term, G1. We've got the common ratio, which remember really is just the multiplier from one term to the next. And up here, n is the number of terms. Okay. Now, if we were to write this out, essentially what we would say is that if I'm trying to do a summation, which is to say I'm going to take that idea of a geometric sequence and turn it into a series, S1 is going to be just G1. And then S2 is G1 plus G2. And S3 is G1 plus G2 plus G3, and so on. But I also know that S1 is equal to G1, of course, that's our starting point. S2, another way of writing S2 is we could say that this is equal to G1 plus G1 times R. Sorry, that's a multiplication symbol there. And then here, S3 could be equal to G1 plus G1 times R plus G1 times R squared. And I could come back here. In S2, I said that this was G1 plus G1R. I could put in here R to the first. And I could put in here up at the first one, I could say this is times R to the 0th power. And it's a little bit odd to think about that, but R to the 0th power is just 1, and so that doesn't really change the fact that S1 equals G1. So what that tells me is that I can put together sort of a generic summation here. I can say that the summation of n terms is going to be equal to G1, the first term, plus G1 times R to the first, plus G1 times R to the second. And I'm going to keep adding those terms until I get to the point where I get G1 times R to the n minus 1 power. And that, you can see we're matching this n minus 1 that I have here. And again, just to point out, S3, the final term is R squared, or has R squared as a multiplier. S2 has a final term with R to the first as R to the multiplier. And S1 has a final term of R to the 0th for the multiplier. So here's our summation for Sn. Now, similar to what we did in the sample, we can take this entire thing here and multiply it by the common ratio, by the multiplier, by R. So I can take this and I can say, well, okay, Rsn is going to be equal to all of these things here multiplied by R. So the first term is going to instead become G1 times R. And the second term is going to be G1 times R to the second. And then we've got G1 times R to the third plus dot, dot, dot. I'm going to have G1 times R to the n minus 1 plus I'm going to have G1 times R to the nth power. Now, just to double check here, the G1 is getting multiplied by R to turn into G1R. This over here is coming from inside of those ellipses. And then the last term in Sn, G1 times R to the n minus 1, that's the term that comes over here and turns into G1 times R to the nth power. Okay. Again, I can rearrange these. So I'm going to stack R Sn on top. And I'm going to call this G1 times R plus G1 times R squared plus G1 times R cubed. Let's come back and make these multipliers. Plus dot 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 plus G1 times R to the n minus 1 power plus G1 times R to the nth power. I'm going to rewrite Sn here. I'm again going to rearrange this a little bit. So I'm going to take that G1, which was hanging out here at the beginning, I'm going to move that to the very end. So here's G1. I'm going to take this G1 times R1, I'm going to start my summation with that guy. And it doesn't matter that I rearrange this here, because I can add in any sequence that I want to, in any order that I want to. And we can see that, again here, we've gotten an arrangement now where these things match up. And if I run a subtraction at this point, I'm going to get, on the left-hand side of the equation, I'm going to get Rsn minus Sn. And then on the right-hand side of the equation, I'm going to get G1 times R to the nth power minus G1. And this is the crux of our equation. From here, we're going to factor both the left and the right side. I get Sn parentheses R minus 1 equals G1 parentheses R to the nth power minus 1. Divide both sides by R minus 1, and I get to the point where Sn equals G1 R to the nth power minus 1 divided by R minus 1. And that's the derivation for our equation. I'll come back in a minute to give us an example of how we might use that.